Welcome back. This is Pre-Algebra Lesson 47, Multiple Graphs Part 2. And today we're going to be talking about how we can make predictions and inferences on different graphs, including line plots, dot graphs, frequency tables, and the favorite seven-leaf plots. So let's look at some of these. All right, one that's pretty common that we see, whether it's in newspapers, on the news, or clearly in work that we're doing in our classrooms. This is called a dot graph. And a dot graph is a graph that shows the relationship between multiple variables that we're studying. Okay, we're comparing one thing to the other. So let's look at the first one. This is comparing the temperature in the degrees compared to the day of the week. So in this case, on Sunday, it was 28 degrees. And on Friday, it was just under 40, so it's 39 degrees. Okay? On our second one, we're talking about high temperatures for Chicago and Milwaukee on different days. And so for this one, in Milwaukee, it was when it was 29 degrees, we can go up to 29, and when we follow it over, we would see that it's 30 degrees in Chicago. Okay, just like if we said it was 34 degrees in Milwaukee, I'm going to go up to 34 on that line, and it would be, oh, look at that, it's 34 degrees in Chicago as well. All right, so I have a question for you, and I'd like for you to pause the video and answer it when you can. Is what was Chicago's temperature when Milwaukee was 40 degrees? Okay, so stop and think about that question. All right, if you said that the temperature was, so when it's 40 degrees in Milwaukee, oops, let me get the pen. When it's 40 degrees in Milwaukee, what is the temperature in Chicago? And it is 42 degrees. So we're following the graph. Very good. All right, let's look at our next graph. This one is called a line plot. You might be familiar with this from previous years of studying math and statistics and math. This is called a line plot. And a line plot shows how frequently the data occurs. So instead of us having a y-axis over here on the side where we're showing the frequency going up and we're creating a bar, as you can see, if we wanted to, we could create a bar around this. We could create a bar that would go around this like that. And instead, we're showing it with x's to represent the data values. So for 30, for the test score of 30, we had 1, 2, 3, 4, 5, 6. And so if it was a bar graph, we'd have the number 6 over here and we would have drawn a line. But instead, we're representing x's for each one of those scores. So each person who got a 30, an x represents that person's score. Okay, so here is my question for you. What is the mean test score for the last math quiz that we took? So we're calling all of these scores for our last math test. And what was the average? Or what was the mean? So in many instances, we are used to hearing mean as average. So how could we calculate that? Well, in this case, what we would do is we would want to add up all of the values. And on your calculator, you would have 30 plus 30 plus 30 plus 30 and so on and so forth. And then you would start adding on. You would go on to add your 35s, however many you had of those, and then you would add your 38 over here, plus 38, and continue on, so on and so forth, till you included all of your values to the very end. Now, certainly what you could do is you could multiply to see, okay, if there's 6 30s, that would be 180. And if there are 4 35s, well, 2 35s, when you put them together, make 70. So 4 35s would be 70 and 70, which is 140. And then we have 2 38s, which would be 76. And then we have 3 40s, which is 130. And then we have a 43. And we have 2 45s, which make 90. And then we have 1, 2, 3 48s. So 3 48s is 144. And 50s, we have 100, 200, 250. So we would add up all of these values. Here we go. There, even down there. And then we would divide by, to find the mean, we would divide by the total number of x's that we have. And so we would want to say, well, how many students took the test? And each x would represent a student that took the test. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So once we got our answer on top, we would divide it by 26, and then that value then would give us our mean score. So go ahead and calculate that. All right, on to our next graph. This is called a frequency table. So we've seen these before. Frequency tables are often used when we're creating other types of graphs, like a histogram or even a circle graph or anything like that. So a frequency chart is just a table that shows how often the data values occur for a given situation. So in this case, we are recognizing that we're looking for the number of cups of coffee, probably how many cups of coffee people drink in a day or on the weekend. I'm not sure because our numbers are getting pretty high. Okay, so that's what they were collecting. They were collecting data on this, and they said, okay, how many people drank 0 to 3 cups of coffee? Well, they were collecting their data using tally marks, and then at the end they wrote their frequency. So they said, okay, we have 2 tally marks, so 2. From 8 to 11, there were 8 people who drank that, and from 16 to 19, there were 2. So you can see how all of the values were determined, collecting the data with the tally marks, and then recording the number under the frequency chart. So the question I have for you guys today is, what is the percentage? Ooh, okay. What is the percentage of people who drink coffee, who drink actually 4 to 7 cups of coffee in a day? So we're trying to see then how many people, 3 people drink, but we want to know what is the percentage. All right, so how would we do that? If we want to find the percentage, we're going to have to figure out what is the total number of people. So it's going to be 3 out of, and let's see, we have 10 and 15 and 18. So it's 3 out of 18. Is that correct? So 14, 15, 16, 17, 18. Yep, it is. So go ahead and calculate, and what percentage would you find? All right. And in our last graph for the day, we're talking about the stem and leaf plot. You probably haven't seen this for a while, so I want to go over it one more time. Again, we're looking at the data. Here's our collection of data that we have, and we're not quite sure what this data represents, but those are the data values, and we're representing it in the display of stem and leaf. And the stem and leaf is a graph that represents values by separating them by place value. So the stem is either our values of 10 or 100, or you could even go into thousands or 10,000s, however high you need it. But the leaves are always just simply going to be our ones place values. And then we can look at our key down here below to show that 3, like for instance this, 3, and then this is our line right here, which is this part, and the 5 on the other side of it, so the 5 would represent the value of 35. And we can see that we have 35 in our data set up above. Okay, so we would have 1 and 2 would make it 12, 1 and 4 is 14, 1 and 8 is 18. And it's listed in order from least. If you notice, the values for our leaves we have the lowest value on this end and the highest value at the end of our row. So it's in order from least to greatest, okay? And then from 23 to 25, and then 32 to 35. Today's question for this graph would be, what is the mode of the data represented? So the mode is what value occurs the most often. So look at the data sets up above, whether you're looking at that or you're looking at strictly the stem and leaf plot, and see if you can determine which data value is represented the most. What is the mode? Okay, for the year turn page, here is a set of data that I'd like for you to try. It's the ages of people at a rock concert. I went to a concert recently. It was so much fun. All of my friends went. So these were the different ages that were given. And I want you to, given this set of data, I want you to create, so here we go. I want you to create two different types of displays of the ones that we talked about today. I want you to use this data and I want you to create it in two different types of displays. And when you're done, I want you to write one good question that somebody else can answer, but this question has to involve some type of a calculation. So whoever answers it is going to have to do some calculation work to find the answer to your question. All right, so copy this problem down into your notebook, create the two different types of displays, and then write a good question in your notebook. All right, we'll see you next time. Bye-bye.